Example 1 asks us to find the components of vector AB whose tail is the point 2, -1, whose head is the point -2, 6. Determine a vector V that's equivalent to AB and has an initial point at the origin. Okay, so I'm going to go 2 pages on this one. Draw it. So the head, the tail is the point 2, -1. So 1, 2, -1 is the tail. That's point A. When you're talking about a vector is a force in a direction, right? The tail is where the point is, where the actual object that's being acted upon is. And the head is where the arrow goes. And if we look at the point -2, 6 is the head, that's point B. So if I were to draw this vector here with the head and the tail the way they've established, it's going to look like this. Let me make that a little bit more forceful. Let's go, boom, all right. So that's the vector we're looking at there. All right. Given the criteria they gave me for the vector, that's what we're looking at. So the thing about vectors is, and that's what it looks like, a vector is a force in a direction. It's not like your regular line. So if I have a line drawn here and another line drawn there, they're different lines, right? Those are the same vector. Doesn't matter where they are, they're the same vector. They're still showing the same force going in the same direction. So it doesn't matter where you put the vector, all these vectors mean the same thing. So what they ask us to do here is determine a vector V that's equivalent to AB, has an initial point, in other words the tail, at the origin. So if you position the vector so its tail's at the origin, we want to determine where it's going to. Let me shrink that up a little bit. That point's so large. All right, so anyway, what you can see is it goes to the origin and it's going to be somewhere. All right, and what we want to do is find the components of that vector, and what we're looking for is horizontally and vertically how far do we go to get there. So I'm going 1, 2, 3, 4 spaces vertically in a negative direction, or sorry, horizontally in a negative direction. Sorry about that. And we're going 1, 2, 3, 4, 5, 6, 7 spaces vertically to get up to this final ending point here, right? So the way we write the vector V, they use these bold letters to represent them. We're going to put a little semi-arrow over it. So V. We write this in component form with a less than symbol, the horizontal vertical components, and then the greater than symbol. The way we've been doing in Algebra 2, is that these mean the same thing. Okay. But for the sake of these problems here, the book puts the answer like this. So let's just go ahead and put the answer like that. Just if we're comparing our answers, we can see that we got the right answer, kind of thing. Now, there's a way to do this without having to graph all this, because I mean we don't like to graph a whole bunch of stuff we don't have to. So if we take a look, the way we figure this out without graphing is the head minus the tail gets you these components. Head minus tail. So if we consider the head is -2, 6, we subtract the tail, which is 2, -1. -2 minus 2 is -4. 6 minus -1 is +7. And once you do the head minus the tail, you go from ordered pair into a component vector structure. But again, if you just head minus tail, the x minus x gets you the x component, y minus y gets you the y component. And it does have to be in that specific order. Tail minus head doesn't get it done. You can have your vector go in the wrong direction. So those problems are dealt with in that manner.